Hello everyone, you are welcome to today's lesson, and in today's lesson we have a simple task. We are going to look at the solution to the lesson 1 assignment of differentiation. So we're looking at calculus, but our concentration was on differentiation, the first aspect of what calculus. Okay, so as you can see, this was the assignment. Okay, you have the solution to the assignment here. I will walk you through, forgive me, through the solution, and you can see some marks there. So once you know this, you've been with me for a while. This is an indication that what we have here, the solution is going to help you mark and submit your marked version, okay, when you are done marking. Okay, so quickly, like I've advised, anytime you read questions, make it a point to underline the salient parts, if any. So here we are going to look at question 1. Evaluate the following. So we are asked to evaluate, and we can see that we are dealing with lame. Okay, questions, limit questions. So now the first thing, you don't have any salient part to underline. So now you come and write solution. Okay, solution after solution, your major question number. Okay, your major question number, is there any information that you can extract on that line? No. Then now you come to your minor question number A. Minor question number, what are you supposed to? You've been given this limit to evaluate. So there's an expression, and when you are evaluating, you conclude with the same expression. So what do? You can write therefore, so that your conclusion will be embedded in your steps or your method. So in this case, what do? Therefore, you extract what you are asked to evaluate. So if you extract B half, then because there's an expression, you introduce your steps with equal to. Take note. So if you use implication, remember, by now it will be M0, A0, because by now you should know. I've said this times, okay, without number on countless occasions. So if you are not learning, then you have to face the full punishment, okay, sort of, or full discouragement for you to do the wrong thing. All right, so now what do? We know, okay, so this is limit of a rational function. Mr. Hackman said, anytime you are dealing with limit of rational functions, okay, our concentration should first of all be on the denominator of that function. So let's see, if you substitute the value that your x is approaching into x, okay, into your denominator function here, will that give you 0? If it gives you 0, then something must be done. You cannot do direct substitution. If it doesn't, then it means direct substitution is allowed. So mentally, 1 squared will give me 1 minus 6 into 1, which is 6, then plus 5. So we'll get 1 minus 6 plus 5, which will give me 0. So obviously, direct substitution will not be allowed in this case. So it means I need to go and work on this so that I will take care of what is not allowing direct substitution. And remember, I said you have two ways of manipulating, okay, factorization and what, and said, or rationalization, I should say. Okay, so rationalization will come in when you see a said term, but here you don't see any said term. So it means the only manipulation that you can think of, okay, will be factorization. Okay, so I have a numerator here, it's not factorable. Denominator is a quadratic expression which is likely factorable. So okay, I have a quadratic expression, so I'm going to write, okay, something here. Okay, this quadratic expression is factorable. And because your concentration is on the denominator, remember I told you, pick whatever that you are working on here. Go and factorize as your rough work and import. So if I have s squared, so my rough work will be s squared, okay, then minus 6x, okay, then plus 5. Thankfully, okay, or fortunately, our leading coefficient is 1. So it means we can factorize, okay, straight away without going through the grouping. So your factors, one will give you x, okay, then another will give you x bracket. Then you look for the factor pair. So the factor pair of 5, which when you add, you get minus, okay, 6 will be minus 5 and minus 1. Okay, so you write the factors here, minus 1, minus 5. So this will be it in terms of the factorization. So by inspection, we know that because the leading coefficient is 1, just a step, okay, you can factorize just as you realize that it was just a step that gave us what this factorization. So it means if you like, you can choose not to do your rough work. If you had the coefficient not of s squared not to be 1, then in that case you cannot avoid the factorization by grouping. Okay, meaning you cannot use only one step to factorize. So if you factorize, okay, your denominator, that will give you okay, 1.5. Then after factorization, this will cancel. Okay, after cancellation, you can see that again you have a rational function. Okay, so you ask yourself again, this rational function, is direct substitution allowed? Okay, so once you can see clearly that direct substitution is allowed, because if I substitute 1 for x in place of x, I will get 1 minus 5, which will not give me 0. So it means direct substitution is allowed. So my next step that I am doing direct substitution, that's where the limit will go. So anywhere here, okay, if you fail to write the limit, it will be m0, a0. Marking becomes easy. Remember, I told you strictly the limit will go when you are doing your direct substitution, carrying out your direct substitution. Otherwise, keep the limit. Okay, so here it is this step that we can do direct substitution, so the limit must go. So in effect, we are going to get 1 over minus what, 4. But remember, I've told you that you don't conclude with a fraction containing a negative in the denominator. So those of you who concluded with this, you won't get the full score. If you wrote 1 over minus 4, okay, you can say that you have concluded with a fraction with a negative in the denominator. No, bring the negative up. Okay, so if you can get the A1, okay, then it means your answer must be in this form. If it is this, it will be A0. Take note. Okay, now that will be it for question 1. So question 1, the total mark, 1A, I should say, the total marks will be 4 marks, just as you can see here. Now question 1B, again, we are finding limits, but limit to infinity. Okay, so remember I told you whenever you are asked to find the limit to infinity, we have to, of any function, and usually it will be a rational function, go and look for the variable with the highest power. Okay, so here we can see all the terms. The variable with the highest power will be x, okay, squared. Okay, so the factor with the highest power, and that will be of x. Now that will be what? S squared. So you take each of the terms in the numerator denominator and divide by this quantity s squared. So that is what is done here. So if we're able to do that, remember, we are not doing direct substitution. So in this case, okay, you cannot write, ignore the limit. Immediately ignore the limit m0, a0. Even if you go and introduce the limit, the next step, it will be m0, a0. Take note. The limit cannot go at this point. So expression equal to, okay, so divide each of the terms by s squared. Then after that, you come and simplify. You know that, okay, let me pick the laser pointer. You know that this s squared will cancel this s squared. So you get 3. Okay, then the x here will cancel one of the x's in the denominator. So that will give you the 5 over x minus the minus 1 over s squared here. You can't do anything to it. Then if you come to the second, the denominator, the first term, again, you can't do anything to it. The second term in the denominator, yes, the s can cancel one of the x's in the denominator. So that's what you have there. And this one to the s squared can cancel the s squared. So you'll be left with this. Okay, so again, your limit should be there. So at this point, you know, at the normal circumstance, you know we are supposed to come and take the limit as s approaches infinity, the limit to infinity of each of the terms here. But you know that anytime you are taking the limit to infinity and you have your variable in the denominator of that function that you are taking limit to infinity, that function will approach 0. So it means this limit of a constant, okay, is a constant. So the limit to infinity of this constant will give you 3. Of this will give you 0. This will also give you 0. Okay, the denominator 2. Limit to infinity of this, because s is in the denominator, will give you 0. Will give you 0 and minus 4. So again, you are going to get 3 over minus 4. But you cannot conclude with that. Quickly, let me do, okay, something here. Okay, your final answer mark there cannot be M1. It's supposed to be A1 instead. Okay, so that is A1. I've done the change, the correction. That's the final answer mark. Okay, so you can see the marks allotted. So this gives you A1. If you leave your answer as what? 3 over negative 4, you won't get the A1. Take note. So you have to end at minus 3 over 4. Okay, not 3 over negative 4. You cannot conclude with a fraction containing the negative in the denominator. Bring the negative up, okay, in your conclusion. So take note. With this one too, we can put therefore here. Okay, in that case, our conclusion is embedded in our steps. Otherwise, then when you are coming to write this, you can write therefore, then come and write the whole of this again, which you know, okay, will take a little of your time. So that's the more reason why we are being smart, because we know what we are giving, we are asked to evaluate is what we are going to conclude with. We won't do anything, and we use equal to, so we can let our conclusion be embedded by writing therefore here. So I guess my point is well made. Now, quickly, let's go and look at. So with this one too, I think the total marks for question 1B is 6. So meaning the whole of question 1 will be what, 10 marks. So now let's look at question 2. Question 2, what are we supposed to find? So we are supposed to differentiate y, which is equal to 2x squared plus 3 from the first principle. So you underline this. Very critical. So this time around, you have something salient for you to underline. And from the first principles, you should know, okay, that there is a particular way that you need to differentiate your function. So if you go and use any other way of differentiating your function apart from the first principle, okay, you will lose the entire marks. Okay, maybe the marks that you get will be your extraction mark here. So here, given y is equal to this, okay, you come and write from the first principle, quote the first principle rule, and take note, because the function came in terms of y, you cannot write from the first principle f prime of x is equal to no. Remember, okay, we said if the function is labeled y, then it means you are asked to find dy dx. If the function is labeled f of x, then you are asked to find f prime of x. So in that case, you quote f prime of x is equal to this. I told you all that. So those of you who use f prime of x here, I didn't know what the plan was because I advised you as to when to use which one. Okay, so take notes. So immediately you write the, okay, that one, you get b0. Okay, let me give you, I'm going to be lenient, so maybe it will be b half. Okay, then now what do you do? In this, okay, formula, the first principle involves a formula, so that's what you've quoted here. You can see that you will need, okay, f, okay, function. So now you go and represent your y by f of x. So f of x will be equal to y, which is the same as this. So instead of writing f of x, let f of x be equal to y, or y be equal to f of x, which is this. You can just write this. Okay, I told you this when we were doing functions as well. Okay, so at this point, we need f of x and f of s plus h. Okay, so once you know f of s, you know f of anything. So f of s plus h will mean wherever you see x in f of x, let me pick the laser so that you can see clearly the pointer. Okay, so f of x plus h will mean wherever you see x in f of s, replace it by what, s plus h. So it means this will be equal to 2 into our new x, which is s plus h. Okay, squared, don't forget that s is squared and it's binomial. You put that in bracket square, then plus 3. So here, remember I told you, do your expansion. Okay, remove all the brackets before you go and substitute. Okay, so heeding that advice, what do? We are going to expand this. And when you are expanding this, at this point, you should know how to expand a binomial squared. So it will be 2, the expansion of this, remember, deal with the power first. Okay, so the expansion of this will give you x squared, which is this, then plus twice the product of s and h, which is 2sh, then plus what, h squared. At this point, you should know how to factorize this. If you don't know how to factorize this, like I always say, it's better to play it safe. So you can still go and take s plus h, okay, squared, you know that is the same as s plus h, x plus h. Then you come and distribute. So this times x times the whole of this, then h times the whole of this. Then you come and combine like terms. Then you import the result. Okay, so if you want to expand this, okay, using the crude way, the basic way, then in that case you have to do that as a rough work and import. Other than that, you write a lot here. Okay, so having expanded that, that was just by the way. So let me go back to my pointer. Okay, so so what do I have? Having expanded this, you know, I dealt with the power. I'm now going to remove, okay, the bracket entirely. So it will be 2 times all the terms here, which will give me what I have here. So now the expanded version of this, okay, full expansion will be what we have here. So it means now I can write therefore dy dx will be equal to the limit as h approaches 0 of your f of x plus h, which is the whole of this, minus your f of x, which is this. But because your f of x is a binomial, you need to put it in bracket. Failure to put it in bracket here will be m0, a0. Your marking becomes very easy. The meaning is different if you don't put it in bracket. So after putting this one in bracket, your next step is to come and remove this bracket. Okay, so we have removed the bracket here. In that case, this will be left intact. Then this will give you minus 2s squared minus what, 3. So, okay, again, what do? You come and simplify the numerator. Okay, so if you simplify the numerator, 2s squared and minus 2s squared will go. Okay, then plus 3 and minus 3 will go. So you'll be left with what? The limit as h approaches 0. You can see that all along you've not done substitution for h. So it means the limit should be there. You know when the limit should go. So if you have any step here where the limit is gone, okay, it means m0, a0, you should know. So at this point, okay, this is gone. Okay, so these are also gone. So you'll be left with what? 4sh plus 2h squared all over h. So you have a rational function. So you ask yourself again, is direct substitution allowed? No, because if h is equal to 0, my denominator will be 0, which is not allowed. Okay, so it means I have to take care of what is not allowing the direct substitution, which is the a. So the numerator, manipulation, we need to manipulate. So the only manipulation we can think of will be factorization. Okay, someone can factorize 2h out, but remember, you are interested in the h. So don't factorize completely. Factorize what will take care of the denominator, which is not allowing the direct substitution. So that's the more reason why you can see h only factored out here. So by that, the h will cancel and you end up getting 4x plus what? 2h, the limit as h approaches 0. Take note again, if you wrote the limit as h approaches 0 and you wrote 4x plus 2h without putting these two in brackets, it will be m0, a0 from that point. Take note. So at this point, what do? We know that this is just a polynomial. And for any polynomial that you are taking limit of, okay, direct substitution is always allowed. So when you are doing your direct substitution, the limit must go at that step. So 4s plus wherever you see h, it will now be 0 because h is approaching 0. So in effect, we are going to get what? 4x. So this will give you a1. So question 2, also 10 marks. So making the total marks, okay, will to be what? 20 marks. So whatever your score is, okay, please, if you had 20 over 20, write 20, okay, over 20. So you should always write your score over the total score. Okay, indicate that one on top of your first page. Okay, when you are sending your marked version of the work. Okay, so take note. I guess my point is well made. And going forward, when you know the rules for differentiation, okay, you should know anytime you're asked to differentiate from the first principle, you'll be able to know whether your answer is right or wrong. You can always use the rule as a check, okay, to determine whether you are right or wrong. Okay, so on this note, thank you very much, okay, for your time and attention. Make sure you do the needful. God bless us all.